Hello everyone. Hi, how are you? Just starting in a minute. Hi Burhan, hi Mason. Walaikum salam everybody. Yes, I'm just starting. All right, so John, thank you for joining in. I'm just starting. Hello Laiba, Mason. Okay. Hmm. Hi. Hello. Walaikum salam everybody. So I'm going to start this and then move off to my black screen so that we can start. Today we're going to be looking at, and I just put on my headphones so that I can hear myself talk also. Yeah. Okay. Yes. Thank you, Saad. I got it a while back. It's an old haircut. It's been going on. So today we're going to start chemical reactions, balancing equations. Then tomorrow or next class we'll be doing moles also. So that's where we're at. All right. Uh, Okay, so basically now people can hear me also. All right. Let me share my screen. Yes. Well, I saw you shouldn't be on YouTube and Zoom. Are you hearing? Are you on both? Or are you on one only? No. All right. Yeah, the setup changed by the way. Okay, it's fine now. All right, awesome. So yes, so there's a little glimpse to the setup because now we're gonna go to the black screen now, the black screen of death. That's what we are looking at. So my favorite part of my favorite part of chemistry just started. Literally, this is what I live for. I can't tell you how much I enjoy doing this chapter, both at the O levels and at the A levels. Yeah, I'll explain to you why. What we are doing is we're going to be talking about chemical formulae, balancing equations, and then types of chemical reactions. Okay. And we did a bit of chemical formulae earlier on in the classes, and those who don't have access to the videos will get them now also. So what we're talking about is what should I call it? And I'll get the black screen for everybody else also. Yep. So now everybody gets to see the black screen. Nobody gets to see my face. That's how the system works. So I'm going to write the name of the chapter, just checking if everybody can see it. And then we'll continue. And this is the second time I'm doing this. Once a couple of days more that goes into this. And then we'll get, okay, Abdul Rahman, that's my goal, to make you all love this chapter. That's why we all do chemistry, don't we? So the reason why this chapter is so much fascinating is because then this chapter will get you to understand basically all that's happening in the universe, basically. Yeah. So I'm looking at chemical equations, understanding them, what they represent, and then they represent chemical reactions, right? They represent what we call chemical change. So we're going to start off with chemical change and then what it means to be a chemical change. All right. Can you guys see my screen now? Am I writing? You can write it. You can see it. Okay. So from now on, again, you'll get the notes uploaded also. Shahzeb, these notes will be uploaded to all platforms that I can find in the next 2 days, and then you'll have them access to them. All right. That works out for you guys. All right. Okay. Awesome. Awesome. Thank you, Mr. Kazi. Sir, we have completed bonding structure. Yes, we have. We have polymers left that I'll do later. And then there is also forms of carbon left that I'm going to separately record as a video and release it to everybody. Been doing this for 5 years now? What? Watching me live stream? What have you been doing for 5 years now? All right. Anyways, so let's start. Abdul Rahman, we're going to make you love this. That's the goal. That's the goal, son. You get it? That's the goal. So where do we start from? That's a good question. We start from the start and at the end. Somebody says that to me. Somebody smart. But it doesn't always work out that way now, does it? Okay. So we have that, and basically a few terms that you don't turn on anything. You just type in the Q&A if you have a question. You can't neither turn on your videos or mics. Shahzeb, this is a webinar setup, not a Zoom meeting setup. For those of you who do want me to look at the comments about questions, you got to sign up for the Zoom webinar. All right. Okay. Well, those who like YouTube can stay on YouTube, either or. All right. So let's start So what we're going to look at is chemical reactions and equations, right? So what do we know about chemical change? Okay. The main feature of a chemical change is you form a new substance. And what can be a substance? A substance can be an element or a compound. So if you make an element, meaning you're extracting an element from a compound, or you can be okay. So yeah, I can't see. I don't know if I turned off the chat feature. I have to turn off the chat feature. That I don't even know how I can turn on the chat feature in Google. Okay. Mr. Kazi, I made you moderator just because you graced us with your presence. You can moderate people's comments if you want. Because if somebody goes out of line, you please reprimand them. All right, so now that we have everybody's attention, this is how this is going to work from now on. Okay, I hope you guys can see the little logo. It's nice. I like the little logo. I'll get mine also and Noon Academy's both going, kind of thing, that kind of thing. Okay, so is it the first class? No, this is not the first class. It's been going on for a while now, and the earlier classes videos have been saved and you can see them later. A lot of you joined this class, and I'm glad the participation is going to make it a little more meaningful class. We got the regulars, you got the Abdullahs, Abdul Rahmans, you got the Burhan, Dilavar, Hassan, Ibrahim, Laiba, Salman, Saad, Ramis, a good few of you. I'm so glad to see you guys back. So, getting back here. So, we're going to be talking about chemical chains. Since we already talked about elements and compounds, and the kind of compounds have different bondings and structures, now we have what we call chemical change, going from one pure class to another. Yes, Rida, now this week onwards, you're going to get 5 classes a week. All right? 3 on Zoom and 2 on Noon Academy's platform. So, I should tell you this before I continue. Yes. Good that you asked that question. So let me just highlight this, and you want to take a picture of this. I'll share this with everybody also on the Noon platform also and everywhere else also. I'm going live across Pakistan and the world, and the idea is that this is how we're going to do this. Tuesday, actually class will be 5 to 6 p.m. on Tuesday to Friday, and 5 to 6:30 on Saturday. Okay, these Tuesday to Thursday will be on Zoom/YouTube. Friday and Saturday will be on Noon. Maybe on YouTube, not sure, but definitely on Noon. All right. Fridays will be answering your questions like an AMA of sorts, and Saturday will be past papers. And plus 1 separate video lesson a week, if need be. So this is 5 classes plus 1 video lesson is what you also do. No, Khadija, we have not covered that. All right. Yeah. Somehow today my feed is down. Somehow I'm not being able to upload the same speed of stuff. Yes, when video will be uploaded on, video lessons will be uploaded on Noon Academy also. Absolutely. All right. Yeah, and they're going on to YouTube also. Yeah, and recorded separately also. Yes, I'm Noman. There's a problem with somehow with the speed. I don't know what's the problem. I'm getting some bad speed right now. Noon Academy, guys, for those of you who haven't, Noon Academy is a free platform that you can join. For you to get access to Pakistani classes, you have to use a Pakistani phone number. So if you don't have one, you can ask anybody in Pakistan who can give you the OTP code for that, or you can call their helpline. They have a helpline number also. Anyways, sorry about the writing. It's really horrendous right now. I know. It's okay. My handwriting is very nice, by the way. Okay. All right. So, is it free learning? Yes, Hadi, it is free learning. All right. All right, guys. So, for those of you in Zoom, hi again. There's something wrong with the handwriting. It's not coming as clean. Is it also not clear for you guys also? Or is it clear to you guys? Because it's definitely bad on YouTube. How is it at Zoom? On Zoom is also a bit blurry? All right. That's so strange. That is absolutely so strange. Okay. I need to shout enhance and it might become better. But it's so okay. Alina just checking in. All right. If it's not a problem, that's great. Okay. So yeah, today somehow I think my internet upload, even though I have 100 Mbps connection, there might be a little delay. So I'm gonna write big and then zoom in so that it's readable. All right. I don't want to waste today's class, so we're continuing with this. So that's the schedule you have for Noon Academy. All right. Okay. And yeah, somehow, yes, Noon Academy is offering O levels and A levels. All right. So moving on. All right. Okay. So now let's go back to what we were talking about. So I was talking about chemical change. So a chemical equation. So basically, chemical equation or a chemical reaction. Equation represents a chemical reaction. So chemical equation represents chemical reactions. Represents chemical reactions. And what are chemical reactions? They have what we call chemical reaction. They basically have they have क्या कहते हैं, they are chemical changes. And what's a chemical change? So that's what I was saying. What's a chemical change? Now, a chemical change is, yes, today it's a little blurry because of speed of the internet, it seems like it. So, okay. No, Saad, Thursday, Wednesday and Friday, Saad. Wednesday and Friday. So, what's a chemical change? Okay. A chemical change is where a new, like I said, a new substance is formed. Is formed. You know, the most easiest example I can give you guys, where did it go? Sorry, is, you know, gas burning on stoves. That's a chemical change. So when you light fire to the gas in the stove, on the stove or your oven, basically it's methane gas that we call natural gas burning. Now that's a chemical change because something is being used up and something else is being made. Can you hear me now? Is it loud enough? Yeah, voice seems fine. I think your audio might be low. Shazib? Yeah, okay. Now it's louder, by the way, but okay, that works for you guys. Yeah. All right. So definitely the YouTube is really, really pixelated and I have no idea why. Anyways, you'll have to figure that one out also. So gas burning on a stove, methyl gas basically, it actually produces, it makes a few things. It makes carbon dioxide gas and it makes steam. So methane, which is another compound CH4 covalently bonded, makes CO2 that's also covalently bonded and H2O that's also covalently bonded. All right. Now the idea is simply that this is a chemical change. Now generally a chemical change also has energy change accompanies it also. Some reactions produce heat and some produce cold for the sake of so basically what was I saying? Yeah, so a chemical change also will have itself a energy change accompanying it. Like for example, like I mentioned, a stove burning is in fact produces heat. Just like in physics you study the law of conservation of energy. So when a reaction produces heat, like when on a stove, the reason why you have gas in the stove is because you want to cook food, so you want that chemical reaction to produce heat. So just like You guys have potential energy because of the height that you possess in a particular room, or when you travel up in air in different elevators and all that stuff. Understand, and chemicals also have something called chemical potential energy. And this is an example of combustion, Abdul Moiz. Absolutely is. Okay? Okay, so Dilawar was asking, how can I tell quickly if something is covalently bonded or ionically bonded, not ironically bonded? I wish everything in life would be ironically bonded, but it isn't. They are ionically bonded and covalently bonded. How could you tell? Well, look at the elements in a formula. If you see the elements in a formula are all non-metals, it is covalent in nature. And I'll give you an idea that the guys on the right hand side of the periodic table, things like carbon, nitrogen, oxygen, fluorine, chlorine, bromine, these are the most popular elements that make covalent compounds. Okay? Because these are the ones that you really need to worry about. These 5. So, and even iodine, obviously. I'm not saying there are not others. There's also hydrogen and iodine. So here are me highlighting, if your compounds have only these elements, which are groups 5, 6, 7 and hydrogen, then you are definitely covalent. Carbon is group 4, hydrogen, carbon, oxygen, hydrogen, oxygen. These are all covalent. All right? Yeah. The gas, no. The gas you heat is called methane. So the gas, basically when you burn that gas that you're burning that comes from the pipes is methane. Yes, somehow Abdullah, I'll figure that one out. Anybody has specific questions about non this chapter but something else? Let's ask them at the end of class. Anything to do with the class dynamics, let's spend the last 5 minutes of class discussing it. All right? So let's talk about chemistry right now. Groups. So groups 1, 2, 3 are metals and transition elements are metals. A good reminder to everybody is, and I'll show this to you, and this is me trying to be polite about this, but it's something that we have done in the earlier classes, is that if you know that your periodic table looks like this, let me just, okay, and then you have this and you can make that, okay, no, delete, then I'm just, let's say I have that. So you got groups 1 here, 2 here, we call these transition elements, and group 3 and 4 and 5, 3, 4, 5, 6, 7, 8. So generally speaking, you got, it's like this. Groups 4, 5, 6, 7 are your non-metals. Okay? But since group 8 doesn't involve solvent bonding, you really have elements that are specified actually. You really realize that there are only a few elements that you have to worry about, and like this, actually. The staircase got screwed up a little bit, it's like this. But yes, so, something like that. Something like that. But what you need to know is that groups 4, let me just actually make it very simple. Groups 4 onwards are generally non-metals, but at the bottom of group 4 they aren't. So basically, you could say like this. But your syllabus only expects you to study what you call it, periods 1 and 2 and 3. So that's why I named them carbon, silicon, nitrogen, oxygen, fluorine, or neon, and phosphorus, sulfur, chlorine, bromine, iodine. This is all the ones you'll be worried about. That's it. The ones I've labeled here. Not even this. Where do the products of methane get oxygen from? From the air. Okay, so that's basically what's a good example to talk about. So first of all, I said methane burns. So whenever you hear the word in English, burning in air, it's about reacting with oxygen. So when I said was this, that methane, which is CH4, burns with oxygen. So burns with oxygen. Now oxygen at room temperature is found as a molecule, O2, to form carbon dioxide and steam. Carbon dioxide is CO2, steam is water. What I've written on top is by fact a word equation. Alright? This is a word equation. And honestly speaking, if you understand this stuff, most of the chemistry becomes easy. How to understand basic chemical changes before we even discuss anything else. So this is the word equation that is highlighted. Alright? Yes, Dilavar, I will be, I am, yes. Okay. Why are we so confused right now is what I want to know. Okay. Okay. This chapter is, I said at the start of class, guys, you guys have to keep up with it. This is chemical equations. The chemical equations. Yeah. Okay. For yourself, Dilavar, or for other people? Okay, yeah, Noman, if there is no oxygen, then there will be no reaction. Absolutely. Okay, so, okay, I will promise you, Dilavar, and that just stick with it for another 2-3 days, and I will make sure that everything else becomes easy and not as confusing. Okay, for you. So, trying to do too much together, I understand that, but that's what we're doing. But that's what we're trying to do. In O-level chemistry, till you hit a certain number of chapters, things take longer. Okay. Shazeb, you gotta stop asking all these questions right now. They're not relevant. Please. Don't make me kick you out of this group right now. Honestly speaking, I love you being here. I want you to teach. I want you to study. But let's not, can we focus our questions only on what we've been studying? And at the end of class, you can ask anything that you want to ask. That is not to do with what I'm teaching you today. Let's focus on today's teaching. So remember, today's class was supposed to be about chemical equations and chemical reactions. And what are equations? Chemical equations are our way of representing chemical reactions. So in chemistry, we don't have to write paragraphs of what's happening. Remember, we like shortcuts. Formulae, for example, equations in physics also, you know, the equations of motions and all that stuff are shortcuts for long explanations. They are just our shortcuts. Okay. And thank you, Andy. Anyways, so what was I saying? So yeah, so what I was saying was that chemical equations are a short way of writing a whole chemical reaction. So instead of me saying methane gas burns in air to form carbon dioxide and water, that's a lot of English. I can just write a chemical equation. And this is the word equation. Then you can write a full equation. I'm going to write a full equation, and don't be confused as to how I got this. But I'm telling you right now, this is the word equation. This is the full equation. Now, a full equation is going to represent a chemical change. New things will form and some things will used up. They will also produce heat. Like this one has a delta H. Delta H talks about change in heat. This reaction produces heat. And this heat is the next chapter after this. So produces heat. We call such reactions exothermic. So after moles, we will do enthalpy changes of reactions. We will do equilibria. We will do all that stuff. Redox also. All right. But Abhi, I'm just introducing you to the idea. So far, all right with you guys? So we said word equation, right? Now, I mean, that's one way. Like if you melt ice, that's not a chemical change. It's still the pure amount of water. But if you were to, let's say, burn methane gas, that's a chemical change. So that's the difference between a chemical change and a physical change. And each chemical change will have chemical reactions. So our job first is to be able to figure out what are chemical equations, why do they are written the way they are, and how do we quote unquote called balance them. All right, that's what we're going to start off with first. Now, if you remember, we just talked about these guys right here, carbon dioxide and water, right? Now, so let's talk about them. How do I make carbon dioxide? Okay, so let's take it extremely basic. Now, if I were to think about how do I form carbon dioxide, now first of all, just to recap a bit of bonding, why am I even making the formula CO2? and this Delaware will help you understand this, is that CO2 has carbon and oxygen. Why did I make CO2? Because carbon's outermost configuration, electron configuration is 2,4, because it has 6 protons. Oxygen has 8, so oxygen has 2, 6. And if you remember earlier on, we did an idea of valency. Valency was the number of electrons needed to share or to lose. So carbon needs to gain 2 electrons, 4 electrons, while oxygen needs only 2 more. So you can say carbon has a valency of 4, oxygen has a valency of 2. That means you need 2 of oxygens to fulfill carbon. So when they even make covalently bonded molecules, this is, I'm trying to make CO2 for you. So this is what happens. There is going to be 2 O's combining. And why is that the case? Because carbon needs to get 8 from 4. So this is a recap of that also. Okay. Oh, that way. Oh, yeah. I know I'm equally confused about the platforms, because we wanted to get the best platform and we want to still try to achieve what we want to achieve this year, is to make sure that I could teach for free to everybody. So by the way, this is really being sponsored by Noon Academy. They are helping me reach out to as many of you as possible. I know some of you were paying students of mine the last 3 months, and that was fun. And I'm still loving that. And however, you remember that. But we're trying to figure out a way that we can help everybody for free. And that's why we had to add the extra platform. And surprisingly, it's like an experiment. You might think it's an experiment, but it's not really. I know how this works, is trying to add more things to it. So in the next few days, this week, everything will sort out extremely smoothly. In fact, I'm going to actually make a separate website just for this class, so that you know where everything is, so that nobody is confused about that. So you'll have links to the Noon Academy group. You'll have links to the videos, you'll have links to the YouTube channel, everything, and you'll know what's coming up next. The classes will be pre-arranged and organized so that you all know what's happening. Yes, we're going to have, you guys are going to be part of the best class in the whole damn world. That's what our job is. And you get 3 more days, you get 5 days, plus a video. That's 6 hours, man. We're going to own chemistry. We're going to literally make sure that this year, this is the best class we have in the world. I'm not playing for the first in Karachi or all of that stuff. All that stuff is easy. We got to be the best. We got to have kids from all of the countries saying, but damn, man, we want that. We want that now. I can't wait. Life's too short. Yeah? We're going to make it. You guys are going to make it. Inshallah. See, understand this. When you guys interact with me, you ask me questions, you probe, that's when learning happens. Because you are fresh minds in chemistry. You guys are young. You guys are, I want to make this easy and fun. That's the goal. And by default, the A grade will automatically happen. You don't have to, I mean, this is not the only way to get an A. You can get an A by doing a lot of boring stuff and not really learning, and learning by heart. Yes. But I want to make sure that's easy to understand and you can solve anything. Then it doesn't matter if you're giving CIE, AQA, EdXL, IGCSE, O levels, you can do everything. When somebody says, what exam are you giving? You say, I don't care. They're all the same to me. You need to have that confidence. And you ask, and I'm so happy to get you guys here, by the way. Honestly, I mean, just seeing 24 kids logged in here and about 14, 15 logged into YouTube, that's about 40 kids. That's a lot of kids. That's a lot of fun. And this is the first time. So we're going to have more of this, by the way. Absolutely are. We are, definitely. So moving along to a recapping of bonding. Yeah. Not this time around. They're going to have the whole year to work on. So they're definitely not doing that. So getting back here. So what was I saying? Yeah. So the way this works is carbon needs to share 4. So carbon shares 2 on one side and 2 on the other. And with oxygen. And what oxygen says is, here, take 2 of mine from here. So these are 2 of the oxygen from the left shared. And 2 of the rights also shared. So this was CO2. 2 double bonds. We can write it like this also. Now, this, we already done this. This are covalent bonds. Covalent bonding. And Today we're going to look at the chemical reaction that made this. So a good and the most simplest way to make carbon dioxide is to take coal, which is carbon, and burn it in air. It produces carbon dioxide, literally. Carbon plus oxygen now produces carbon dioxide, first of all, right? Now you might notice here that I've written carbon as C, but oxygen as O2. And this is stuff that you'll have to start knowing by heart, that which elements are going to be found in what form at room temperature. Carbon is found as carbon at room temperature, C. In fact, we call this version graphite. And I'm going to give you a video lesson on the different forms of carbon this week, separately, pre-recorded. All right? Coke is one. Yes, scientists like to call it Coke. It's not the same Coke as you might have seen in some movies, nor is the same Coke we drink. But it's carbon black soot Coke, of course. Thank you, Moise. Yeah, not that one. Saad, absolutely not. This is lemons. This is live. This is as live as it can be, baby. This is an hour-long class. Lemon. I like your lemons. When life gives you lemons, you drink lemonade. Methamphetamine. Dilaver. Yes. Thank you for. Yes. Not that even. This is Coke, just as carbon. All right. That's the one I'm saying it's not. Eh? Abdul Mohit, thank you so very much for introducing us to things that we should not be talking about in this class, please. It ain't cool. Okay. All right. Yeah, that's the same Coke. Shazeb, it's the same Coke. Coke means carbon. Coke means an impure form of carbon with impurities. Yes, absolutely. So the point here that I was trying to show you guys is that to make carbon dioxide, which is a covalently bonded molecule, we will react carbon and oxygen. But before we even go to balancing equations, all right, what we have is, first of all, awareness about how some of these elements might be found at room temperature. So today I'm definitely going to talk about hydrogen being H2 and oxygen being O2 and chlorine being Cl2. You know, let's at least focus on these three. These are three elements found as diatomic elements, molecules. And why? Because they react with each other to make bonds. So we've done bonding earlier, and yeah, so hydrogen, oxygen, chlorine, these are found as already bonded molecules. So when I'm saying that I want to take carbon and burn it, what I'm saying is literally this, and this is what's happening at the molecular level. What I wrote this equation, it has an accompanying diagram that I'm just going to put here. Very nicely done. This is what's happening. So what was happening was, one carbon atom was an individual. One molecule of chlorine had two atoms of oxygen bonded. What they did was they broke this bond, and that can happen. So in a chemical change, you'll realize many times a bond can be broken. And if you remember CO2's shape that we had drawn on top, right there, you see this? This is CO2. That forms by making two new bonds. Shazeb, not all gases are diatomic, but right now they seem to be. Yeah, so we'll stick with that. But not all gases are diatomic. Okay, that's what we have. So, getting back here. So what was I saying? So here, this is what I call a chemical equation. Now, what's some certain features about a chemical equation? They have to do with the law of conservation of mass. Before anything else, you know that in physics you've studied that a mass cannot be created or destroyed. So when you look at laws of conservation of mass, what that translates to in chemistry is that the atoms for each element on the left hand side, meaning atoms of carbon, equal to the atoms of carbon on the right hand side. Same with the atoms of oxygen have to equal on both sides. And that's how you know your equation is correct. Here, if I look at the left-hand side, the arrow tells me what was before the reaction and points to what is after the reaction. So before the reaction happened, I took carbon, which is coke, and burned it in air. Literally, one atom of carbon will react with one molecule of oxygen, which we know as O2. And that breaks and forms CO2. But what is that if you notice something, the right hand side has the same number of carbon atoms, 1, and so does the left hand side. And the right hand side has 2 oxygen atoms and 2 oxygen atoms. And that's generally how we like to write equations. Generally, this is an easier one, but that doesn't happen all the time. Remember, it is to do with the fact that a chemical equation has to be balanced. And when we say balance, it just literally means that equal number of atoms on the left hand side and equal number of atoms on the right hand side. All right. So I'm going to get you some more diagrams right now. Yeah. Why is there a reason? I don't understand. Manaf, what do you ask? Well, it's like bonds, like things sticking to each other. So for oxygen to combine with carbon, the word combine in chemistry means bond. So to make a new substance, you have to make new combinations, new bonds. And the only way you can make new bonds if you break already existing bonds. And why do the things even make new substances? In chemistry, we discussed this, that the reason why anything happens is because, and I mentioned this last class, didn't I? Is that things become more stable. So basically, the reason why even this is happening is because carbon dioxide is a much more stable form than these two. That's why they are called highly reactive, because carbon dioxide isn't reactive, it's stable. So the why a reaction happens, we'll study a lot more later in O levels and definitely more in A levels. But for now, let's say that we know this happened. The only way this can happen is if the only way oxygen can make new bonds with carbon to make carbon dioxide is if it let go of its already existing bonds. That's the only way this can happen. And so we will look at what's happening inside to the atoms in a chemical change in more detail in terms of energy later. But what's really happening is that there's some energy required, and these attraction or combination is broken, and so oxygen is then free to make new combination. If it can't break, it can't make new combinations. That's the thing. Now, this is one example of carbon and oxygen reacting. Now, the problem is that's how carbons are. That's how, oxygen is. It's always bonded. Now, if I wanted to do that with magnesium, for example, and this is something that this is something that, let me make it, like, have you heard of lime? Now, calcium is a metal, okay? And, so so I don't want to worry about the limestone is calcium carbonate. I don't want to focus ourselves only on covalent structures. So because I want to talk about nuts. You see, when you look at chemical reaction, you can see the atoms reacting, and you can also see what's happening inside. What's happening inside is bonding, and I'm talking about the overall picture. Like, for example, I tell you that I can burn calcium, burns in oxygen to form calcium oxide. Let's say this information is known to us. I'm telling you this information. Using this information, how can you represent this information? Now, you might wonder, well, एक second, what form is calcium? So we've done bonding, so we know that calcium is a metal, so it has metallic bonding that we did last class. Then we know that oxygen is a non-metal, and so we know that it exists as found as what form? Can you guys remember? I just told you guys oxygen is always going to be found as what? Come on, I'm waiting. What's the formula for oxygen found as? It's found as a diatomic gas O2. That is, each atom is covalently bonded. Yes, thank you guys. Thank you all of you. Awesome. So, and by the way, now calcium oxide is definitely a compound. It's not an element, because how do we know it's a compound? It's got two different elements into it. But what kind of compound is it? If both are non-metals, it's covalent, but they're not non-metals because calcium is a metal and oxygen came from a non-metal. Oxide is the anion of oxygen. And remember, before we even did bonding, I did with you anions and cations, ions of elements, right? Yeah. So it's a compound, but it's got a metal and a non-metal. So like somebody said, Khatija said, it is an ionic compound. So to understand the overall change, we had to do bonding first. So we did bonding. Now it's an ionic compound, and its formula is Ca2 plus and O2 minus. And we had done this in ionic bonding. How did it become that? Calcium, and this is the bonding part, not the equation part. The calcium was 2882 that lost 2 electrons. And oxygen atom gains those 2 electrons to become oxide ion, because 2,6 became 2,8. And 288 became 28. 2882 became 288. So these elements became ions to form an ionic compound. And now to represent all of this is what we call an equation, because the equation would be calcium plus oxygen forming calcium oxide. Somebody who's as anal as me might even want to show the ions of calcium oxide just so that he can show in people's faces that, hey, look, I made an ionic compound. But because the charges are equal, it's overall neutral anyways. So we have that. Shazeb, half equations we're going to look at when we do redox, by the way. I'm not going to look at them right now. I'm looking at only full equations. I'm not writing a half equation. I'm writing a full equation here. All right? Yes, in compound, oxygen won't be diatomic. Absolutely, Moise. The earlier you learn that, the better it is. Diatomic is only and only when it's pure. So, also, chemistry does require you to learn some things. So, one way is to explicitly learn it. The other is to keep showing you again and again so that you guys learn it. Like one of them is this. Oxygen, as in a pure element form, is diatomic, but in compounds, it has to be balanced according to what you know. All right? Like the charges and all that stuff. So far. All right? Yes, Zahir Abbas, this is live, baby. Is this as live as I can be? I'm alive. Absolutely. Zahir Abbas can't fathom it. He's got 3 question marks after live. Or 2, sorry. It's alive. Alive and live both. Anyways, getting back here. So this is a chemical equation. But so we've done bonding. Remember, there's a sequence of how I did the chapters. Elements, formulae, then then all that bonding. And then from bonding, now we got to rewrite. So basically, this is a chemical change. Elements reacting to form new substances. New substances definitely even have other bonding. So they have ionic bonding. This was covalently bonded. This is metallic bonded. Even in just one equation, we are experiencing 3 bondings. Metallic, covalent, and ionic. And by the way, even this reaction has heat exchange. There is, and that's a separate chapter later. The heat changes that accompany a chemical reaction is a whole different chapter. Metallic versus ionic bonding, what's the difference? The difference is this, guys. The difference is this, very simply speaking. Okay. I did mention this, but since this has come up from a gentleman who takes it becomes an ion, so we look at its valency. Yes. Okay. Okay. So yes, I could tell you all of the things that you need to learn, because there's so many. Like there's no one list, Saad. They'll keep coming over and over again, and so I can't make one list of things that you have to learn. You know, just like you have to learn that non-metals have sharing electrons, but that information comes in bonding, so you learn it in bonding. Look, very simply speaking, somebody asked this: metallic versus ionic, what's the difference? That's a big difference, Abdul Muiz. Metals, Zoya, we'll talk about ionic equations later. We're just starting out reactions right now. Ionic equations come later. Okay, ionic equations are just equations. They've just been made different by people asking. All right, Zahir Abbas. I don't do A-level. I'm an A-level student. Great. Though I'm not doing A-levels live yet. Yeah, but okay, sure. Anyways, goodbye. The title does say O-level IGCSE chemistry, doesn't it? All right, Zoya, later. Basically, Abdul Muiz, metallic bonding is what you find in metals. Ionic bonding is what you find in compounds that are bonded ionically, because the compounds are made of metal and non-metal. All right. So you guys have, okay, so, okay, there is a Q&A section, by the way. Yes, please. Yeah, guys, the chat is always very confusing. Thank you for highlighting, Saad. There's a Q&A section. Nobody writes there. It's resting in peace. Agreed. I'm actually looking at 3 different chat sessions right now, and that's distracting me from even teaching, by the way. Yes, thank you, Hassan Shah. Yeah. I think by the end of 2 classes, I'll only focus on Q&A. Yes, Rida, I know. 8 minutes left. So, obviously we can't do everything in one class, right? But, so the point of chemical equations was this, that you have to be able to balance it also. Now, clearly there are some discrepancies of people understanding of bonding also. So I've got to give you an overview of all the way bonding connects, because unless you figure that out, you can't really balance equations, because you have to also see the atoms. The key here, the key to balancing equations is the atoms on the left hand side for calcium are 1, and the right hand side is also 1. But oxygen seems to have 2 atoms here. You see, when you add O2, you mean there are 2 atoms that are combined. On the other hand, the right hand side has O that only has 1 atom, and that becomes a dilemma. They have to be equal. These 2 have to be equal. So how do I make them equal? Either, and this is what we do in chemistry, either we multiply one side by something or the other side. So either I multiply 2 by something and then they become equal, or I multiply 1 with something for them to be equal. Now, one traditional view says multiply O by 2, which means that if I multiply this side, this whole substance by 2 right here as a coefficient, then I'll get 2 oxygens, won't I? Now oxygens are equal. But it's about, the problem is, we put 2 here, then now you're also changing calcium. It's no longer 1, it's become 2. Yeah? And so, oh, now you got to make this 2, so you make that 2. How? By putting 2 here. And that's one way of balancing it. Because what does balancing mean? Balancing means equal number of atoms for each element on both sides. So now you got 2 calciums here, and I've got 2 calciums here. Now this 2 coefficient that is before calcium oxide means I've got 2 whole calcium oxides, meaning 2 of calcium and 2 of oxygen. So I've got 2 ions of calcium and 2 atoms of oxygen oxygen on calcium, which is what I have here also. So that's one way of balancing it. Let me show you another way of balancing the same thing. Now that might require you to use fractions. Okay, let me write that again. So calcium and oxygen had become calcium oxide. Forget the ions, forget everything. All right. Now remember, the subscripts, the small letters that come after it are bonded. You cannot change them. You can only and only put coefficients before it. So this is you can only put coefficients before the whole structure to balance. When I start looking at it, okay, the left hand side has 1 calcium, the right hand side has 1 calcium. The left hand side has 2 oxygen atoms, the right hand side has 1. Now I told you there's one way that we could balance these two is by multiplying this by something else, right? By 2. If I put 2 here, these two become equal. Agreed? Do you guys agree with that? The other is, can somebody tell me what could I have put? Like this is asking a kid math, So if I had 2 times a box, what could I put in the box to make the oxygen atoms equal to the right hand side? I can put a half. And that's exactly what we do. Absolutely. Yes. So the half comes here. So that's another way of doing this, by the way. Putting a half here. Okay. Abdullah, this class is Monday, Tuesday, Wednesday. Okay. And Friday, Saturday. Okay. Yes, so you can put half, you can put a decimal 0.5, whatever you like. Yes. This is also balanced now. So now, because half of 2 is 1. We just don't like to use half too much, but you can use half. And if you don't like half, I tend to tell people, take half and then multiply the whole thing by the denominator, 2. And you'll get 2, 1, 2. That's another way of balancing it. Absolutely. Not Monday. Sorry. Tuesday, Wednesday, Thursday, Friday, Saturday. Not Monday. Not Sunday. And 2 days on Noon, 3 days on YouTube. I do hold A-level classes. Dave, it's on Teaching Circle. You can go to Teaching Circle's website. All right. I wrote that for today. Okay. And I'll just upload that. It's 3 days a week. I did that here. I said, let's ask this question. Okay. This is what we have, guys. Clearly, we didn't do much today, but we will have to speed up the process. All right. And so these are the schedules. All right. Thursday, Tuesday, Wednesday, Thursday, Friday, Saturday. And Tuesdays and Fridays classes will be taken by Mr. Abul, and Tuesdays, Thursdays, and Saturdays will be taken by me. But tomorrow he's going to continue on chemical equations. Yes, for sure. All right. It's a 1 hour class, Khatija. It seemed shorter today because we finally got down to sorting this out properly. So yeah. So now this is the system, and a video lesson is me pre-recording a video late night and uploading it on YouTube. Mr. Abul, I don't know if some of you have already been taught by him. He takes tutorials on Saturdays. He'll be taking class on Fridays and Tuesdays, Wednesdays. Yeah, he teaches with me. We teach together. It's a team. It's a team effort. All right. So as in asking about what? So for this duration of the whole course, this is going to go on till April, first week of April. I mean, we're going to go on till May, but the syllabus will end by first week of April. That's the goal. Okay. No, Zoya, you said no to where? I don't know what you asked. No till. All right. No worries. All right. Okay, there was something else. All right. Yeah. I'll share the Zoom link on a post on my YouTube page also, and the Zoom link is already shared on Google on Noon Academy's website, and I'm going to literally change this now. Stop my screen, okay, and get my camera out. No, wrong camera. Okay. Yeah. Oops. Yeah. Yeah, the wrong camera. I'm right here. Anyways, so the class is over, and so why does crypto now? Do you have any other questions that you want to ask at the end? Yeah, so somebody asking which days are you live on? Well, all days will be live. They will be live Tuesday, Wednesday, Thursday, Friday, Saturday. All right. And some of you are still here. Yes, that's me right there again. Okay, so what was that? Okay, you can, Saturday will be enough, but you can practice them on your own also. Absolutely. Okay. The third shell can have, so what was the question? You guys should put the question in a Q&A so it's easier to see. I can't find. Okay, so where was the question? Okay, because mesom, the third shell can take 18 electrons. The fourth shell can take 32 electrons. That's how. There's no limit. Shazeb, there's a bio teacher on the Teaching Circles platform and a bio teacher, I believe, on the Noon Academy's platform. Yeah, I don't teach bio. I've taught AdMath and physics, but not bio. Currently, I'm only teaching chemistry because that's all I have time for. So that's okay. But you could check out, I believe Noon Academy will have bio. I definitely know the Teaching Circle has a bio teacher. So you can check a look with her. All right. Do you play games? Because I saw the GE Force experience pop up. No. Where the I did not see a GE Force experience anywhere. Yeah, sorry about that. No. I don't know where that popped up. I don't know. Yeah. Graphics card? No, I don't have a GE graphics card. I do, in fact, have a Mac, but no graphics card. I don't play games, no. Yeah, I used to. Counter-Strike, way 20 years ago, 15 years ago. Not anymore. All right. Yes, we will be doing past papers on Saturdays. Absolutely. All right. Okay. Okay, I have no idea what those are. Okay. Okay, anyways. Thank you, guys. All right. I'll see you guys next class. And all right. Bye-bye.